Hello friends, today we are going to see about the applications of uniform circular motion. And the first one is vehicle along horizontal circular track. Vehicle along horizontal circular track or horizontal circular road. See, whenever anybody is moving along a plain road, whenever anybody is moving along a plain road and there are so many turns. So while turning, each and every vehicle is performing circular motion. So now we can say that we are moving along horizontal circular track. We are moving along a horizontal circular track. And whenever any vehicle is moving along a horizontal circular track, the vehicle is performing circular motion. And so for circular motion, centripetal force is necessary for the circular motion. Centripetal force which is necessary for circular motion. And we know that, rather you know that, the centripetal force has formula mv square upon r. Centripetal force has formula mv square upon r. So now the vehicle is moving along a horizontal circular road. And while turning, so this is a horizontal circular road, you can say. This is a vehicle. So what are the forces that are acting on this vehicle which is moving along a horizontal circular track or horizontal circular road? What are the forces? See, the basic thing is that if any body is along the table, there are two forces. Any body, whatever may be its shape, there are two forces acting on this body. One is its weight, which is acting vertically downward. Its weight mg, which is acting vertically downward. And the second force is normal reaction. Second force is normal reaction, which is perpendicular to this road. So again, see, any body is there and this body is there on the table. Say it is on the table. Then the first force is its weight acting vertically downward. And the second force is normal reaction, which is perpendicular to this surface of the table. Normal reaction, which is perpendicular to this table. See, the meaning of normal line is the perpendicular line. Normal means perpendicular line. So see, let us move towards this vehicle. This vehicle is along the horizontal circular track. And this C is the center of that circular track. Then what is the distance between the center of the vehicle and this center of the circular track? R, small r, is the distance between the center of the circular track and the center of the vehicle. Now see, what are the forces acting on this vehicle? One is the weight mg, which is acting vertically downward. And the normal reaction N, which is perpendicular to the surface of the road. And there is a force of friction Fs. Between the wheels of the vehicle and surface of the road. Wheels of the vehicle and the surface of the road. And as the vehicle is moving along circular path, centripetal force is necessary, and that centripetal force is provided by force of friction. The centripetal force is necessary for the circular motion as the vehicle is moving along horizontal circular road. Circular motion is there, and for circular motion centripetal force is necessary, and this force of friction between surface of the road and wheels of the vehicle, this force of friction, it provides the centripetal force. So this force of friction, it is equal to mu s n. This force of friction, it is equal to mu s n, and which is equal to mu s mg. So this centripetal force, it is equal to mu s n. What is mu s? It is the coefficient of static friction, and n is the normal reaction. And we can see that from this figure that this normal reaction is equal to mg. So this force of friction, it is equal to mu s, coefficient of static friction, into n, which is equal to mu s n equal to mg. And we know that the centripetal force is equal to force of friction. So centripetal force, we know that centripetal force has formula mv square upon r. Centripetal force has formula mv square upon r, and it is equal to fs, force of friction. What is force of friction? It is equal to mu s into mg. So this m get cancelled. This m get cancelled. And this v square upon r, what we get? V square upon r equal to mu s into g. So v square equal to this r, mu s r g. And v is equal to square root of mu s r g. So this is the formula for the maximum or most safe speed for the vehicle is moving along horizontal curved road. This is the formula for most safe speed or maximum velocity for the vehicle which is moving along horizontal circular track, which is moving along horizontal circular road, which is moving along horizontal curved road. So what is the formula for this maximum velocity? It is equal to square root of mu s r g. What is mu s? It is the coefficient of static friction. Coefficient of static friction between the surface of the road and the wheels of the vehicle. What is r? It is the radius of the circular track. It is the radius of the circular track, and g is the acceleration due to gravity. So this is the formula for most safe speed when vehicle is moving along horizontal circular road. And you can see that this formula does not contain mass of the vehicle. This formula does not contain mass of the vehicle. That means the most safe speed or maximum safety speed limit for any vehicle, whether it is a car or whether it is a loaded truck, for each and every vehicle, whatever may be the mass of the vehicle, the most safe speed limit is v equal to square root of mu s r g. You can say that this most safe speed for horizontal circular track or horizontal circular road is independent of the mass of the vehicle. It is independent of the mass of the vehicle. And that's why along any road, the most safe speed limit is written. And it is written that the 20 km/h is the most safe speed. So they are not saying that this is the most safe speed is for car or this is the most safe speed is for the truck. So you can say that the most safe speed along horizontal circular road is independent of mass of vehicle. So this is the first application. This is the first application for vehicle along horizontal circular track or horizontal circular road. And what is the formula? V equal to square root of mu s r g. You can say that this most safe speed depends upon coefficient of static friction, radius of circular track, and acceleration due to gravity. And now we will move towards the next application. We will move towards the next application, second application of the uniform circular motion. Second application of the uniform circular motion. And this second application for the uniform circular motion is, the second application for uniform circular motion is well or what? Of well or wall of depth. Well or wall of depth. So see, in a circus, there is a motorcyclist. There is a motorcyclist. There is a cylindrical wall in a circus. And the motorcyclist, it will cover that or it will move along that horizontal circles. So see, this is the wall of depth, you can say, in a circus. And along this circular path, that motorcyclist, it will move along this circular path. And that motorcyclist, he or she, whoever it may be, it will move along the circular path without falling. And here is the physics behind it. So see, suppose that this is the center of that cylindrical wall. This is the center of cylindrical wall. And this is the position of the motorcyclist, which is moving along that horizontal circle in well of depth, or you can say in a wall of depth. So this is the position of the motorcyclist. So what are the forces acting on that motorcyclist? First one, weight mg, which is acting vertically downward. And now see, this is the wall of depth. So the normal reaction is perpendicular to wall. So the forces acting on the motorcyclist, which is moving along horizontal circles, and this is the position of the motorcyclist. What are the forces? One is mg acting vertically downward. Then force of friction Fx, it is acting upward, and the normal reaction, which is perpendicular to the wall. And now the motorcyclist, it is moving along this horizontal circle. And this is the center of the path. So this is the direction of centripetal force which is required. As motorcyclist is moving along this horizontal circle, this is the direction of centripetal force. So this normal reaction is acting acting or this normal reaction provides the centripetal force for the circular motion of the motorcyclist, which is moving along the wall of death, which is moving along the wall of death. See, from this figure, we conclude that this Fs and mg, they are same. We conclude that these Fs and mg, they are same, rather they are equal and opposite. They balance each other. So Fs equal to mg. But we know that the static friction, it is equal to mu s into n. We know that the static friction, it is equal to mu s into n. What is mu s? We have seen. What is mu s? It is coefficient of static friction. And n is this normal reaction. And we know that this normal reaction provides necessary centripetal force for circular motion. So this n, which is equal to centripetal force, mv square upon r, which has this formula also, mr omega square. So this normal reaction, it provides centripetal force mv square upon r. And we know that this Fs equal to mu s. Fs equal to mu s. So Fs equal to mu s n. Mu s n. So what is n? N equal to the centripetal force. So mu s n means mv square upon r, and this mg. So again, see, what are the forces acting on this motorcyclist? One is the weight of the body, mg, acting vertically downward. There is a force of static friction acting vertically upward, and the third force is normal reaction, which is perpendicular to this wall. And this normal reaction provides the necessary centripetal force. And so this Fs, it is equal to, we have seen mg, but this Fs is equal to mu s into n, according to the formula for the static friction. But we know that this normal reaction is equal to centripetal force mv square upon r. So mu s into mv square upon r, and it is equal to mg. So what we can do here, cancel m, you will get mu s into v square upon r equal to g. Then v square equal to rg upon mu s. V square equal to rg upon mu s, and this v equal to square root of rg upon mu s. So the velocity or the speed, which is necessary for the horizontal circular motion along the wheel of death in circus, is equal to v equal to square root of rg upon mu s. It is equal to square root of rg upon mu s. Again, this velocity, which is necessary for the horizontal circular motion along the wheel of death or along the wall of death, it does not depend upon the mass of that motorcycle or mass of the motorcyclist. So whatever may be the mass of that motorcycle, bike, or whatever may be the mass of that motorcyclist, this velocity, which is necessary for the circular motion, horizontal circular motion along the wheel of death or along the wall of death, it is equal to square root of rg upon mu s. Again, this velocity does not depend upon the mass of the motorcyclist and motorcyclist, which is moving along the horizontal circle in wall of death or in wheel of death. So today we have seen two applications of uniform circular motion. First one is the vehicle along horizontal circular track or horizontal circular road. And in that case, we have seen that the most safe speed, v, it is equal to square root of mu s rg. And the second application, we have seen that the wheel of death. And for for the horizontal circular motion along the well of death, the necessary velocity, necessary speed is equal to square root of rg upon mu s. And so today we have seen two applications of uniform circular motion. And in the next lecture, we are going to see about the banking of ropes. So for this lecture, thank you.